All right, let's dive right in. Today, we're going to peel back the layers of hype and really get into the technical guts of large language models, specifically from a computer scientist's point of view. We'll look at the scale, the architecture, and the absolute game-changing innovations that make all of this possible. So, I'm willing to bet you've used something like ChatGPT. But for us, the really interesting question isn't just what it can do, but how it does it. What's the actual machinery taking away under the hood? Let's take a look. Okay, so at its very core, an LLM is a deep neural network. That's the foundation. It's been trained on a truly mind-boggling amount of text, and its primary goal is actually pretty simple: predict the next word in a sequence. That's it. But when you apply that simple goal at an unbelievable scale, you get these incredible abilities to generate text and understand what we're saying. It's not magic, it's just really, really sophisticated pattern matching. That brings us to the very first word in the name, large. I mean, why isn't it just a language model? What does large really mean here? Well, it all comes down to the size of the model itself. This. This is what large looks like. 175 billion. This number represents the parameters. You can think of them as the knobs and dials inside the neural network that get tuned during training. Just in GPT-3 alone, there are 175 billion of them. It's this sheer quantity that allows the model to capture all the subtle rules, nuances, and complexities of human language. Now, check this out. This table really shows the trend, and it is just exponential. You can see a direct connection. As the number of parameters and decoders skyrockets, the model's ability to handle more complex ideas and remember things over longer stretches of text goes up too. The leap from GPT-2 to GPT-3, that's 100 times increase in parameters. It's a massive jump in what the model can do. This is a perfect example of scaling laws in action. And this chart really puts that growth into perspective. For most of AI's history, model sizes were, relatively tame. But then look at what happens around 2018. The line just goes vertical. That's when these new architectures came on the scene. This isn't just a simple increase, it's a fundamental shift in how big we can build our models. Okay, so they're huge, we've established that. But how did that size actually change the game for natural language processing, or NLP? Well, it all has to do with a big shift from specialized models to ones that can do, almost anything. This right here is the key difference. Before LLMs, NLP was all about single tasking. You'd have to build and train a specific model just for translation, and then a completely different one for sentiment analysis. But LLMs changed all that. Now you have a single giant pre-trained model that you can just prompt to do all sorts of things, from writing an email to generating Python code. It's the difference between having a toolbox full of individual wrenches and having one incredibly powerful all-purpose multi-tool. A leap forward like this doesn't just happen by slowly improving old tech. It almost always requires a major breakthrough, some kind of secret sauce. And for LLMs, we can actually point to the exact moment, the exact innovation that made this whole revolution possible. And this is it, the title of a paper from Google Brain in 2017 that just changed everything. Attention is all you need. To give you an idea of its impact, this one paper has been cited over 100,000 times in just a few years. That's absolutely staggering. It was a seismic shift. So what was in that paper? The transformer architecture. Its secret weapon was the attention mechanism. This allowed the model to weigh the importance of different words in a sentence, no matter how far apart they were. This solved a huge problem that older models had, and critically, it allowed for parallel processing. That meant we could finally train models on the massive scale we're seeing today. With terms like AI, machine learning, and deep learning getting thrown around all the time, it's easy to get confused. So let's take a second to map out where LLMs actually fit into the bigger picture. The best way to think about it is like a set of Russian nesting dolls. The biggest doll is artificial intelligence. That's the whole field. Inside that, you have machine learning, which is all about systems that learn from data. Open that one and you find deep learning, which uses those multi-layered neural networks. And then finally, the smallest doll inside is large language models, a very specific application of deep learning that uses architectures like the transformer. And to make it really concrete, an old rule-based chatbot from the 90s, that's AI, but not machine learning. An email spam filter that learns over time, that's machine learning. An app that can identify a dog in a photo using a neural network, that's deep learning. And a model that can write a sonnet about that dog? That is a large language model, a very specialized kind of deep learning focused entirely on text. So, we've seen how massive scale and the brilliant transformer architecture have pushed us into this incredible new era. But, this kind of exponential growth can't go on forever. And that leaves us with some really big questions. Are we about to hit a wall with just making models bigger? Will the next great leap come from even more data and parameters? Or do we need a completely new architecture, the next transformer? That is the challenge and the opportunity that lies ahead.